Welcome to MyProjectBazaar.com.
Now we discuss about the product for compact MIMO antenna for portable UWB application with band notched characteristics. Next we see the abstract for the product. Multiple input multiple output technology with the potential of increasing channel capacity without of requiring additional frequency spectrum power has been drawing much attention. A MIMO communication system requires using multiple antenna installed in the transmitter and the or receiver with low coupling between them. However, for portable device where the space is very limited, installing for portable devices of MIMO antenna with low coupling is always great challenge for antenna designers. Various MIMO antenna have been studied for uses portable devices in different wireless systems such as LTE and WLAN, and the study showed in the MIMO technology used in the ultra wideband system would provide the superior channel capacity over the used in narrowband systems. The UWB from 3.1 to 10.6 assigned for the FCC to unlicensed use overlaps with the WLAN frequency band from the 5.15 to 85 to the band notched characteristics in WLAN applications. A multiple input multiple output band notched antenna with a compact size of 22 into 36 mm squared, the proposed portable ultra wideband applications. The antenna consists of square monopole elements, a T-shaped ground strip, a vertical slot cut to the T-shaped ground strip to reduce the mutual coupling of two strips for the ground plane to create the notched frequency band. Simulation and measurement are used to study the antenna performance in terms of impedance matching isolation between the two input ports are the result of envelope collision coefficient and radiation pattern and peak gain and efficiency, all the things. The results to be showed in the antenna characteristics operate from 3.1 to more than 11 GHz with a notched band in 5.15 to 85 GHz for our notched frequency. This to improve the good return loss and gain level improvement for using the band notched characteristics. Next we see the flow diagram for the antenna design. We implement the antenna design using the HFSS software. This software to implement the high frequency synthesis simulator based frequency development and the bandwidth calculation to be all the designs and developments to be included in the HFSS software. So first we open the new HFSS software and new project design in our 3D model based designs. Then create a new project design. Then go to first we create the any one of the antenna. First we choose the substrate model, and to analyze the substrate model and the dielectric constant value and permittivity value and the dielectric substrate modeling type, all the things to be noted. Then we select and create the patterns for and the shapes for our substrate model, because example for circular or rectangular or square or triangular based substrate model used in our any one of the HFSS modeling designs. Then we apply the which substrate model to be implemented. Example for Roger or Roger 54003 or 5005. So then to apply the substrate model, then we go to the assign substrate material type. The material is represents the same like a Roger material, and we go to the patch model design. Whatever patch model we use, the circular, square or rectangular patch model to be implemented in our designs, and we using the polyplane for cut, rectangular shape cut, all the things, and we add and subtract the implement design and to connect the what are the patch model implement in our secured diagonal patterns, and we implement the XY Z dimension based substrate model design in our secured selected new project. Then we go to the to design the bottom patch and top patch design. Every model consists of the ground plane and the top plane structure for our required patch wise designs. When the substrate to be included and the multiple substrate model and the 3-layer model and all the things to be designed in the first design based process. In every antenna design, we implement first the design phase completions process to be calculated. Then we go to the final design phase process.
After design process to be completed, then we go to the analyze setup work for every antenna design. The analyze setup mainly focused by the boundary wise designs and the excitation wise designs in our field setup. Whenever you use the electrical field and we use the waveport model, and the magnetic field we use the step up port model for overall antenna designs. These designs to be applied for the frequency range. Then to set the frequency for a start and stop frequency and the solution frequency. The solution frequency to be changed based on the antenna model designs, and whatever we working the full bandwidth and to coverage with the center frequency range for our required solution frequency model. Then to set up all the frequency model and to run and the overall process. Then if the run to calculate the S parameter, and it's like return losses for our required antenna design, then we go to the empty boundary box to be set up for our required antenna model design, and to set the radiation pattern. This radiation pattern to set the pattern wise model for our required 360 and 180 degree pi and theta value for setup for our overall radiation pattern. Then to calculate the radiation pattern graph and the polar plot graph and the gain level and all the things VSWR, each and every analysis for required antenna design to be calculated for our required model, final model. This is our the final flow diagram for the antenna design process.
Finally, we see the output for the product. This is our the project to HFSS and out HFSS file. Just to double click the project to designs. This is designed to include the MIMO based antenna design for two square based monopole antenna shapes. This is our required pre-model designs, and final design is 7 to be included for overall architecture design. This is our the boundary box for required radiation patterns processing. This is our the ground plane T-shaped structure for required our band notched characteristics purpose. This is our top plane structure for required rectangular monopole antenna shape based on the square shape model. This is our another one mirror shape model for our architecture designs. This is our the feedback structure for our required antenna design. This is our the rectangular model. This is our the overall diagrammatic representation for our required MIMO based two square monopole antenna design. Just to simulate and synthesis our overall designs based process. Just to design the overall design, then to view the results based on our required antenna working level. This is our the notched frequency band for 5.15 to 85. This is our the overall working level for our ultra wideband coverage frequency level. This is our the radiation pattern. This is our the polar belt graph for our required gain model for MIMO antenna design. This is our the final output for the product.